Hey guys, welcome to our review for the multiple choice questions that were asked for me to go over in the big theorems packet. So listed right here are the multiple choice questions that I will be going over in this video, and then the free response questions that you asked for will be going over in a separate video that will be posted later. So first off, question number 6. Not the easiest question. This question also is a calculator active question. So if I forgot to tell you that ahead of time, I apologize. But yes, you are able to use a calculator for this question. Okay, so we are asked to let f of x equal the antiderivative from 0 to x squared of sine of t dt. At how many points in the closed interval from 0 to radical pi does the instantaneous rate of change of f equal the average rate of change of f on the interval? Okay, well, let's talk about how, first of all, anytime you're asked where the average rate of change is equal to the instantaneous rate of change, that is your mean value theorem, okay? That goes back to that idea of the graph where somewhere along the line on this graph, all right, if I take the slope between the endpoints, somewhere along the line that will equal my tangent line equation, that they would get the same slope, right? So at this point, and actually there's probably another one, maybe right over here, that all three of those lines would have the same slope. So that is a point where your average rate of change, which is this one, would equal your instantaneous rate of change, or again, the slope of the tangent line. So that is mean value theorem. That is what you are asked to find here in this question, because again, they're talking about where the instantaneous rate of change is equal to the average rate of change. Now, the first thing that can kind of be confusing is that I'm given the function not in the initial f of x format, but I'm actually given it in the antiderivative format. So even though it says f of x is equal to the antiderivative of sine of t, so that actually means that the function that we're actually dealing with here is negative cosine, all right, of t, because sine of t is the derivative of negative cosine. So that would be my derivative function. But the actual function that we're dealing with here is the negative cosine of t. The other thing that's actually important is that they give me this interval from 0 to radical pi. Those are two x values, right? So I've got x, the first x value is 0, and the second x value is radical pi. However, what's important to note is that in the antiderivative statement, we're actually not just going from 0 to, from one x value to another. We're going from 0 to x squared. So if I plug this x value into my antiderivative bounds, right, I actually have to take x squared of this term, and so I get pi here. So that means my actual interval that we're really dealing with, which again can be very confusing to get this, the actual interval that we're dealing with is from 0 to pi, not just from 0 to radical pi. 0 to radical pi, yes, those are two x values, but when I plug them back into the actual integral statement, that tells me I have to take x squared, not just the x value as is. So that's super important. That is the overall interval that we are going to be looking at, not just from 0 to radical pi. Now, again, we just said before that this is the mean value theorem that we're discussing. I want to know where the average rate of change is equal to the instantaneous rate of change. So we find the average rate of change with our standard slope formula that we learned way back in Algebra 1. All right, some of you guys might remember that as y2 minus y1 over x2 minus x1. In calculus, generally, we think about it more as f of b minus f of a over b minus a. And my instantaneous rate of change is the slope of the tangent line, which is our derivative statement. So again, when I am plugging into the average rate of change, I am using my f of x, which was the antiderivative of sine, which is negative cosine. So I'm going to plug in the appropriate values here, right? So, and we're dealing with the interval from 0 to pi. So that means I have negative cosine of pi minus negative cosine of 0 divided by pi minus 0. And that's equal to my f prime of c. Well, we have to come over here to our handy-dandy unit circle. And remember that at 0 and pi, my coordinate on the unit circle is 1, 0 and negative 1, 0. All right, sine is the y value, cosine is the x value of those coordinates. So if I have negative cosine of pi, I need to look at the x value at pi, which is negative 1. And this minus the negative, I can just rewrite as plus. And cosine of 0 is the x value at the coordinate at 0, which is positive 1. And pi minus 0 is pi. So this ends up being 1 plus 1, which is 2 over pi, is equal to the derivative. So what does this pretty much tell me? This is saying that in order to fully answer this question, I need to know where is my derivative function equal to 2 over pi. And actually, more specifically in this question, it's asking how many times does that occur? Okay, now my derivative function was the derivative of negative cosine. That's what actually showed up in my original integral statement, right? That original integral statement, that function is my f of prime. So I pretty much need to know where is the sine function equal to 2 over pi. How many times does that happen? So what we're going to do is we are going to take our calculator, and you want to make sure first of all that you are in radian mode, right? Everything in AP Calc is in radian mode. So that's the first thing that you have to make sure you check. Then you're going to go over to your graphing tool, and you're going to plug the sine function into y1, and you're going to plug 2 divided by pi into y2. Because again, I need to figure out where do these two functions meet and how many times does that happen. Then you're going to go over to your window function, and you are going to change the bounds so that this is a better picture for you. So I would say that your x minimum should be 0 and your x maximum should be pi, because that was the interval that we're looking at from 0 to pi. I would also change the y min and y max just so it zooms in a little bit better. I'd probably do maybe like negative 1.5 to positive 1.5, right? Because your basic sine curve just goes from negative 1 to positive 1. So I'd like to give it a little extra room just to visually see everything, but it's up to you. And after you have the window and everything set, you're going to hit graph, and you should get a picture that looks like this. So I can see that my sine graph, my y1 is that red curve, and my y2, the line 2 over pi, is that yellow curve. And again, the question was just how many times are these two things equal? Well, how many times are they equal? You're asking yourselves, how many times do those graphs connect? And that is, they connect 2 times. So your answer here is C. And again, why is that the answer? Because we were trying to figure out where the sine function is equal to 2 over pi. Why are those the two things that we're checking? Because sine is my derivative function, my instantaneous rate of change, and I was asked to find where that instantaneous rate of change would be equal to my average rate of change, and my average rate of change was 2 over pi. Okay. All right, moving on. All right, question number 9. So these are some of the questions where, generally I leave them for our specific review to go over them, so I wasn't able to do specific questions like this in class. So if we have the graph shown above, we're talking about the antiderivative from 1 to 3 of f of x dx equals 2.3. Okay, before I even read the rest of the question, if I am given that from x equals 1 to x equals 3, my antiderivative is 2.3. Well, that 2.3 is the area under the curve. Don't forget about what your integral statement represents. It represents the area under the curve. So that means from 1 to 3, right in there, that area under the curve is 2.3. Now, let's go to the next thing. They tell us that the derivative of capital F is f of x. Well, that makes sense because if little f is in my integral, that means capital F of x would be the antiderivative of little f of x. So going in the opposite direction, the derivative of capital F of x would equal little f of x. Okay, so that's just kind of restating the obvious from the information that we were given. All right, so then it says then f of 3 minus f of 0. Well, f of 3 minus f of 0 is our fundamental theorem of calculus. That's the f of b minus f of a we do after we take the antiderivative of something. So if I were to take the antiderivative of f of x, little f of x, right, I get capital F of x, and then we evaluate it from a to b. And so we get f of b minus f of a. And so if they want us to do f of 3 minus f of 0, that means that in back to the original function, I now wanted to look for the interval from 0 to 3. What does that mean? That means I want to find the area under the curve now from 0 to 3. Rather than from 1 to 3 like the information we were given originally. So what does that mean? That means that I need to find the area under the curve from 0 to 1 because I already know the area under the curve from 1 to 3 is 2.3. So if this is 2.3, because that was the information that they gave us, all I have to do now is find the area under the curve from 0 to 1. Well, there's no calculation really for me to do. That information is given to us. I can figure it out from the graph. From 0 to 1, I've got this lovely little rectangle with a width of 1 and a height of 2. So 2 times 1, that area under the curve just from 0 to 1 is 2. Add them up. That means my total area under the curve from 0 to 3 is 4.3, which was choice D, and that would be our answer for question number 9. On to question number 10. Now, here's another calculator question that you're given. Obviously, if you didn't know that ahead of time, you could know that just from the answer choices that are given. Anytime you're given answer choices that go to 3 decimal places, it has to have been a calculator question. All right, so we're saying that let g be the function given by g of x equals the antiderivative from 0 to x of sine of t squared dt. All right, on the interval from -1 to 3. On which of the following intervals is g decreasing? All right, well, if g is decreasing, that means my slope of g has to be negative. All right, so if my function is decreasing, what do we know about that? That means that its slope is negative. So let's come over here. I'm going to then take the derivative of g of x, which means I want to take the derivative of the antiderivative of sine of t squared dt. Well, this is one of those fundamental theorem of calculus part 2 tricks that we did. If you take the derivative of the antiderivative, you just kind of end up back at the same function. And we're going to take this x value and just plug it in for t. So that means that my g prime function is sine of x squared. That's a messy 2 there. All right, the sine of x squared. All right, so that's my derivative function. That's the derivative of the original function. Okay, so I want to know, where is this function negative on the interval from -1 is less than x is less than 3. So we're going to go over to our calculator, and into y1 we're going to plug sine of x squared. And we want to make sure that when we plug in sine of x squared, all right, it's the x squared that's being, it's the x that's being squared, not the entire sine function. So x squared should be within those parentheses. You also want to change your window. All right, so you go to the window button and change your x minimum to -1 and your x max to 3, because that was the interval that we were told to look at. And I apologize with my drawing skills, but I can't get a screenshot of my calculator. So here's what the graph kind of looks like for me after I plug it in. I was still, for the window, I was still on the y min and y max of -1.5 to +1.5 from our last problem. And I think those are still good y min and max values. All right, so I want to find where the interval is this is my g prime of x. This is the, whoops, didn't mean to hit that, pardon me. All right, technical difficulty. This is the graph of g prime, okay? So again, I want to know where g prime is negative. Wherever g prime is negative, that's going to tell me where my original function is decreasing. Well, I can see very clearly where g prime is negative, right? It's right here. Wherever it is under the x-axis, that's where my function has negative values. So what I need to do is I need to figure out, okay, what is this x value and what is this x value? Now, the answer choices are far enough apart where, you know, you could just kind of move your cursor and get an estimate. However, you know, if I move my cursor over without doing any calculations, I get this to be about 1.766, which again, I can see isn't actually any of the answer choices. And I can see if I just move my cursor over, that this ends up being about 2.532. Again, not one of the answer choices, but the answers that are close enough are choice D. Those are going to be my actual answer choices. But let's just kind of go through how we would get this exact value, because there are some times that the answer choices are a lot more specific and closer than this, and you wouldn't be able to just use your cursor back and forth. So here are kind of the steps that we're going to have to do to find what this exact value would be. So on your calculator, you're going to go to second trace. That brings you to the calculate function. Now, because these two values that we're looking for are actually roots, they're zeros on the function, right? They're where they cross over the x-axis. So we can go to option 2, which is 0, right? Because again, that tells us wherever we have a root or wherever we cross over the x-axis. So you're going to hit enter, and then it's going to ask you 3 questions. It's going to ask you for a left bound, a right bound, and then your guess. So pretty much the calculator can't find both of these points at the same time, so you have to kind of zoom in on which point you want to find which time. I know we kind of went over this quickly once or twice in class, but that was a while ago, so that's why I just wanted to kind of go back through the steps. So for this point on the left, this one here, I'm going to type into my left bound. You could either move your cursor or you could kind of just type in a value. So I can see that 1 is definitely to the left of the point that I'm looking for. So I'm going to type in 1. All right, and sometimes you'll see this dashed line, or you'll see like this little arrow come up like, okay, this is the furthest to the left that the calculator is looking. Now the right bound, I can't go too far to the right where I'm also including this second point. So I have to pick somewhere in between the point that I'm looking for and that extra point. So you know what, x equals 2, that's right there in the middle. So I'm going to choose that as my right bound. And then when it says guess, I usually don't actually type anything in. You could just hit enter again, and it'll come up that this x value here is 1.772. And I can see that that's now the exact value that choice D had to offer. Okay, now really you only had to find that one x value. That's the one furthest to the left. That would be the one on the left side of the interval. So again, we can kind of automatically assume it's point D. Otherwise, you can go through these same steps, and then I would be choosing x equals 2 for the left bound and x equals 3 for the right bound for that other point, and we would get that 2.507 that is also in choice D. Okay, hopefully that was helpful. Let's go on. Question number 11. So question number 11 is definitely a AP style question, but it's also one that you have to be careful of. You have to pay attention to detail. That's what's super important with all these questions, paying attention to detail. Okay, so where do they start off? They start off with g prime of x is greater than 0. So as you know from past questions, I like to kind of take notes as I'm going through these questions. I didn't read the back part of the question yet, but I'm going to just start taking a note. So if g prime of x is greater than 0, that means g prime of x is positive. That means my slope is positive. So that means my original function is increasing. All right. Now, g double prime of x is greater than 0. Well, g double prime talks about my concavity. So if my concavity is positive, that means my original function is concave up. So two things that I have figured out from this problem without even reading the rest of it. Okay, so if I have a function that is increasing and concave up for all real numbers of x, that would look like something like that. Okay, now they tell us that g of 4 is 12, and they tell us g of 5 is 18. And so I want to know which one could be a possibility for g prime of 6. Now, C, D, and E are all answers that are above 18. So because I'm an increasing function, it would make sense that g of 6 has to be larger than 18. However, the big thing here is the fact that we are concave up. That's what's really going to narrow this down. Okay, if my concavity, if I had no concavity, right, if g double prime of x was equal to 0, that means that I have no concavity. That means this would have been more of a linear function. And then I would have had the same slope. And if I had the same slope, well then this, again, I added 6, and then I would add 6, and I'd end up with a y value of 24. However, they told us that I don't have a concavity that's equal to 0. Therefore, this is not a linear function. Therefore, I can't just keep adding the same slope over and over again. I have a concavity concave up. That means that my graph has to be more exponential in its look. So again, I'm just going to kind of redraw this. Exponential in its look. So that means as I get further and further along in my x values, my y values are going to grow at a faster rate. So I have to choose the y value that would have grown at a faster rate, and that would have been 27. Okay, 21 would have been the choice if we were told that I was concave down, because then if I was concave down, that means that my function would have been slowing down. And so then it would have made more sense to go from, let's say, 12 to 18 to then 21, because again, as I'm going up a concave down function, my slopes are decreasing. All right, they're getting smaller. My second derivative is going to get smaller and smaller. So that would be, if I was concave down, I would have chosen choice C. If I had no concavity and it was a linear function, I would have chose 24, but the fact that we are concave up leads us to needing a faster growing function, my slope to increase at a faster rate. That leads us to answer 27. Question 13. These are the questions that you guys all seem to hate and not want to remember. Pretty much what this is telling us here is that this is my g prime function. Okay, that's the fancy way of saying what's happening here. If g of x is the antiderivative of f of t, well, this is f of t, that is the derivative of your g of x function. So if I want to know where I have a maximum, they're talking about a relative max. And again, your relative max is where you go from having a positive slope to a negative slope. And so when you're looking on your derivative function, you want to know where you're going from above the x-axis to below the x-axis. Remember, this only happens where you cross over the x-axis. You're going to get a relative max or relative min. Well, the only place that happens is right there at choice C. That's it. That's where you go from g prime, your slope, going from a positive value above the x-axis to a negative value below the x-axis. So that is your only relative max. You have no relative min on this function because there's no place that you go from a negative slope to a positive slope. Okay, question 14. Kind of tricky, but definitely doable. Again, what the AP loves. All right, first thing that we're given is that g of x is less than 0. And we're given what f prime of x is. So if I was trying to graph my f prime function, first of all, if g of x is less than 0, that means that this has to be some sort of negative number. Okay? So that means that f prime of x, I'm just going to say, again, if I distribute a negative 1, just making this up. But if this became x squared minus 4 times, again, let's say a negative 1. It could be any negative value. But if I distribute, that means that's going to be a negative x squared and a positive 4. Now, if you have a negative x squared, that means your polynomial is flipped upside down. And again, this plus 4 would mean that you are shifted up by 4. Now, in this problem, the two roots of this function are at 2 and negative 2. And again, remember, this is the graph of f prime. So what is it now asking? It's asking for relative max and relative mins. Same thing what we did last time, last problem. So right here, okay, this is where your f prime of x equals 0. This is a critical point on the graph. Same thing over here. Here's another critical point because it's where f prime of x equals 0. These are the only possible places that you could have a relative max and relative min. Now you're looking, do I go from below the x-axis to above? Because this means that you have a negative slope, a negative f prime, to a positive slope or a positive f prime. So right here, if I go from a negative f prime to a positive f prime, or a negative slope to a positive slope, that means that I have a relative minimum on my original f of x function. Over here, we go from a positive f prime to a negative f prime. That means we're going from a positive slope to a negative slope. So at x equals 2, we have a relative maximum on my original f of x function. And so that leads us to having choice B as our answer. Question 15. Okay, so they give us an interval from A to B. They tell us that A is less than C is less than B. Okay, meaning that's the order that we have to go through with our values from left to right. But they tell us that there's a relative maximum at C. So here are kind of the two different graphs that you could have. All right, and they want to know which of the following statements must be true. Not can be true, but must be true. Now, in this case, somebody was asking how to explain if you are differentiable from a graph. Remember, you're differentiable anywhere that you are curved. All right, but having this sharp edge here, okay, you are not differentiable at that point. So that means at this point, f, your derivative statement, doesn't exist. So that means choice 1 here, f prime of z, exists. That does not have to be the case in order for you to have a relative maximum. Okay, let's move on to the next one. If f prime of c exists, that would be this situation, then it has to be a slope of 0, absolutely. Okay, if your f prime exists, in order to have a relative max, your slope would have to be 0. You have to get that horizontal tangent line. And then if f double prime exists, that's talking about your concavity, you'd have to be concave down. Absolutely, I can't have a relative max without being concave down. So 2 and 3 are your correct answers.